Hello everyone, welcome to my YouTube channel. I am Dr. Injamamul Haque, currently working as assistant professor at the Department of Mathematics, School of Computer Science and AI, SR University, Warangal. Today I will discuss rank correlation, an important concept in statistics used to measure the relationship between the variable based on their ranks. In this video, we will focus on Spearman rank correlation coefficient, which is useful when data is given in the form of rank or order. By the end of this lecture, you will understand the concept, interpretation, and the calculation of rank correlation through the examples. So first, uh, we will recall, as we have discussed in the previous video, the simple correlation coefficient. So there, uh, we have discussed about the Pearson correlation coefficient, which is given by this formula R equal to n into summation of x y minus summation of x into summation of y by square root of n into summation of x square minus summation of x whole square into n into summation of y square minus summation of y whole square. So this is Carl Pearson correlation coefficient we have discussed in the previous video. So now we will solve some more problem based on this simple correlation coefficient. The already we have discussed about that the correlations, simple correlation measures the relationship between the variable. Simple correlation coefficient quantify this relationship, and it is also the R is lie between the value -1 to 1, and it help understand the direction and the strength of two variables. So we will discuss some more problem based on this simple correlation coefficient. Suppose that a researcher want to check whether the two variables is collected from an experiment are related, then the observation are given x and y as a 1 4 2 1 3 3 4 2. Then in this question we will find the simple correlation coefficient with the help of the formula Carl Pearson coefficient. Okay, so now we will make the same table as we have discussed in the previous video. We will make the table for x, y, x square, y square, x into y. What is the value of x? 1, 2, 3, 4, right? Here the value of 4, 1, 3, 2. Then value of x square will be what? 1, 4, 9, and 4, 4, 16. Okay. Y square is what? 16, 1, 9, 4. What is the value of x into y is? 4, 2 into 1 is 2, 3 into 3 is 9, and 4 into 2 is 8. Now what is the value of summation of x? The summation of x will be equal to 10. Summation of y will be equal to also y4 1 5 3 8 to 10, and summation of x square will be equal to what? 30. The summation of y square is what? Summation of y square is equal to 30, and the summation of xy 4 to 6 9 15 8 23, xy equal to 23. So these are the things: summation x, summation y, summation x square, summation y square, and summation x into y. Now we will apply the formula called Pearson correlation formula, that is R equal to, as we have discussed, R will be equal to n into summation xy. Here n is equal to the what? 4, because the number of total observation is 4. That's why n equal to 4 into 23 summation of xy minus summation of x is equal to what? 10, and summation y is also 10. That's why 10 into 10 right? By square root of what? N into summation of x square. So that is 4 into summation x square is 30 minus summation of x whole square. So that is 10 square is what? 100, right? Into this will be equal to what? 4 into summation of y square. Summation of y square is 30 minus summation y whole square is 100. So this will be equal to the what? If you find this, then we will get the value r equal to minus 0.4. So the simple correlation coefficient r equal to minus 4, and this indicate what? This indicate the weak negative linear relationship between x and y. As x is increases, y tends to decreases slightly, but the relation is not strong. So we can write that this as a the simple correlation coefficient r is minus 0.4. Right? This means what? This indicate a weak weak negative linear relationship between y. Okay, so that means if x is increases, y tends to decreases slightly, but the relationship is not strong. So this is all about the simple correlation coefficient. So now question is that, as we have used the simple correlation which is depends on actual numerical values, but in many practical situations we only have ranking instead of exact data. For example, rank of the student or preference of individual. In such cases, the usual correlation formula is not suitable. So the natural question is, how do we measure the relationship in such a data? So this motivate the concept of rank correlation. Now we will discuss about the rank correlation. First, we will define the Spearman rank correlation coefficient. The rank correlation coefficient and is a statistical tools or method which is used to measure the strength and direction of relationship between two variables based on their rank rather than their actual value. It tells us whether when one variable increases, the other tend to increases or decreases in a predictable way. This method is especially useful when the data are qualitative, ordinal, or when exact numerical measurements are not reliable. So the most widely used rank correlation measure is Spearman rank correlation coefficient, and we will denote it by this as a rho. So we'll got the definition of Spearman rank correlation coefficient. So now we will discuss about the range of the Spearman rank correlation coefficient. So now here we define the Spearman rank correlation coefficient, as we have discussed that it is denoted by rho. So if x and y are two variables with the rank assigned to their observation, then Spearman rank correlation coefficient is defined as rho equal to 1 minus 6 summation d square by n into n square minus 1. Here n is the total number of observation, d is the difference between the rank of corresponding observation, and d square is equal to the sum of square of rank. The d square is nothing but this is the sum of square of the rank difference. That is, d is nothing but this is the d is what difference between the rank of their corresponding observation, and d square is equal to the what sum of the square of rank of differences. So this is the formula to finding the rank correlation coefficient. This is known as Spearman rank correlation coefficient. Okay. Now, as similar to the Carl Pearson correlation coefficient, the range of Spearman rank correlation is also lie between minus 1 to 1. So now if row equal to plus 1, then the two variable will be perfectly positive correlation. Then it will be perfectly positive correlation, right? If row is lie between 0 to 1, then it will be positive rank correlation. Positively rank correlation. This will be perfectly rank positive positive rank correlation. Positive rank correlation. If rho is equal to 0, then we can say that no rank correlation. No rank correlation. Okay. And if rho lie between minus 1 to 0, then we can say that the two variable will be negatively correlated. That is negative rank correlation. Negative rank correlation. Okay. And if rho equal to the minus 1, then it will be perfectly negative perfectly negative rank correlation. Okay. So now we have discussed here about the range of the Spearman rank correlation coefficient. So now we will discuss about the interpretation of rank correlation coefficient. So if the positive rank value means what? Variable are moves in the same direction. If the value means the variable move in the same direction. Negative value means variable move in the opposite direction. Value close to 0 means weak rank correlation between the variables, and value close to plus minus 1 means strong rank correlation. So now we'll discuss about the properties of the rank correlation coefficient. It is also as a simple correlation coefficient, it is also unit free. This is also unit free. Okay. Second things is what? It is also dimensionless. It is also dimensionless. Similarly, this is also symmetric. That is rho of x y is also equal to rho of y x. Okay. So this is the property of rank correlation coefficient. Okay. Have the monotonic relationship. That means relationship does not need to be a linear. In case of rank correlation coefficient, the measures would be what? Monotonic relationship, because this relationship does not need to be a linear, and this is also less effective by the outliers, means it is extreme observation affected only the rank position. So these are the properties of rank correlation coefficients. Okay. So now we will discuss some problem to understand this definition. Okay. So before discuss the problem based on this rank correlation coefficient, let us compare the Spearman versus Pearson. So we can say that the Spearman is what? Now we'll discuss about the relationship between the comparison between Spearman and Pearson. So first here write that feature, here row, and here rank Pearson. This is what? Spearman, and this is what? Pearson. So this is data type. If you discuss about the data type, so it will be what? Based on the rank. Okay, this is based on the rank, and this is based on the quantitative. This is based on the quantitative, right? And if you usage, discuss about the usage. So it use the rank and it use the actual value, it use the actual values, right? And if you discuss about the relation, you discuss about the relationship, then it will be what? It will be monotonic, right? It will be monotonic, but it will be the what? Linear. And if you want to discuss about the assumption, discuss about the assumption, then there is no assumption in case of Spearman rank correlation coefficient, but in case of this is normally required, right? And if you discuss about the nature, so nature is what? This is non-parametric. This is non-parametric. But the simple or Carl Pearson parametric. Okay. Typical use. If you discuss about that, typical use, then it is most preference. This will be preferences mostly, and this is used properly for the rank, and this will be used for measurement or score. Measurement and score. Okay. So these are the comparison between the Spearman rank correlation and the Carl Pearson correlation coefficient. So now we'll discuss some numerical problem based on Spearman rank correlation coefficient. This is the first problem. Here given that 5 students are ranked based on the math and statistics performance. The student A, B, C, D, E are given and with their rank in math and stats. So here we will find the Spearman rank correlation coefficient. Then we will interpret this result. Okay. So now here the student here rank R1 is, that is rank on mathematics. This is R2 rank on statistics, and this is D, and this is D square, right? So what is given? Student A, B, C, D, E. Okay, and rank is 1, 2, 3, 4, 5. But in statistics, this is 2, 1, 3, this is 5, this is 4. Now we find the difference between their rank. So this is 1 minus 2 is what? Minus 1. This is what? 2 minus 1 is 1, and 3 minus 3 is 0, and 4 minus 5 is minus 1, 5 minus 4 is 1. Now we'll find the D square. This is 1, and this is what? 1, this is 0, this is 1, this is 1. Now we'll find the summation D square. So summation D square is equal to the what here? This is nothing but 4. So now here we apply the Spearman rank correlation coefficient formula, rho equal to 1 minus 6 into summation D square by n into n minus n square minus 1. So here 1 minus 6, as we have find that summation D square is equal to the what? 4. So this is into 4 by n equal to what here? 5. 5 into 5 square minus 1. So this is equal to what? 1 minus 24 by 5 into 25 minus 1 is 24. So this is equal to what? This 24 is cancelled. So this is equal to 4 by 5. So this is equal to 0.8. Means what? This is strongly positive correlation. That means these two variables are strong positively correlated. This is strong positive correlation. Okay. So this is all about the Spearman rank correlation coefficient. Okay. So now we will discuss another problem. Here the rank in two tests are given. Here the rank X rank and Y rank for the two tests are given here for the sample 1, 2, 3, 4, 5. So here we will find the Spearman rank correlation coefficient. Then we will interpret the result. Okay. So similar way we will make the same tables. That is what here will be what simple. Here R1, here R2, here D, here D square, right? This is 1, 2, 3, 4, 5. One have a rank 1, 2, 3, 4, 5. And this have a rank is what? 3, 5, 1, 4 and 2. Now we will find the difference. 1 and 3 is what? Minus 2, minus 3. This is 2, this is 0 and this is 3. So that's why this is 4, this is 9, this is 4, this is 0 and this is 9. So summation D square equal to what here? 4, 9, 13, 4, 17, 17, 9, 26. So here we can say that 1 minus 3 is what? Minus 2, 2 minus 5 is minus 3, 3 minus 1 is 2, 4 minus 4 is 0, 5 minus 2 is 3. 2 square 4, 3 square 9, 2 square 4, 0, 3 square 9, 4 9 13, 13, 4 9 13 and 9, 4 9 13 17 and this is 26. Okay. Okay. So now we'll again, now here we apply the Spearman rank correlation formula. That is what? Rho equal to 1 minus 6 into summation D square by n into n square minus 1, right? So 1 minus 6 into summation D square. D square is what? 26 by 5 into 24. So this is equal to what? 1 minus 1 minus this is 6 6 36 15 by 120. So this is equal to what? 120 minus 156. This is minus 36 by 120. 6, 20, 3, 10. So that is 0 minus 0.3. So we can say that this is negatively correlated. This is what? Negative rank correlation. Rank correlation. Okay. So this is all about the negatively ranked correlation. Now we'll discuss the next problem. So now we'll discuss another problem. In this problem, we can see that a practical education teacher want to determine if there is a relationship between the number of hours a student practice and their final test score. Data is collected from 8 students is as following. Here the rank is not given. Here in this question we can say that the rank of the student is not given. Okay, so student and their uh, uh, hours, the number of hours student do the practice is given in this questions. So in this question, first we will find the rank of this student, then we will find the rank Spearman rank correlation coefficient. Okay. So the problem is that how can we find the rank of this student? Okay. So we will find the first we find rank of x and y. Okay. To find to find rank for x, rank for x, here given as 8 hours. So we will give the rank. To find the rank for x, we will assign the rank 1 to the highest value. We will assign rank first to the highest value, that means those will get the first rank will get the highest score. That means we will determine the rank based on their study hours. That means who give the more practice will get the first rank, and then subsequently will give the rank. For 8 hours, we can see that the maximum practice are 8 hours, and this is for the student D for the data X. That's why we will give the 8 hours for the D student as a rank 1, as a rank 1. Then 7 hours for student E will give the rank 2, and for 6 hours for the student G, the rank will be what? Rank will be 3. For 5 hours for the student B will be rank 4. For 4 hours, 4 hours for student F will be what? Rank 5. For 3 hours for student C have the rank 6. Have the rank 6. But we can see that there are two students who practice 2 hours. 2 hours by the student what? A and H. In this situation, there are rank 7 and 8 will be the tie. 7 and 8 will be the tie. That's why we will take the average rank of 7 and 8. That is 7 plus 8 by 2. That means this is the 7.5. Means what? The rank for the student A and H will be the 7.5. Why? Because we can see that A and H have the same practice hour. That's why we will take the average of rank 7 and 8. That will be 7.5. In the similar way, we will find the rank for Y. Rank for rank for Y. So we'll get that we can see that the student D got the 595 as a first rank, as a first rank 1. That is rank 1, and 90 got by student G will got rank 2. 85 by the student E will got rank 3, and 80 by the student B got rank 4, and 75 by student F got rank 5. By student C got 70 having rank 6. 65 got by student A rank 7. Then 60 by student H got rank 8. So in this way we have find the rank for the student corresponding to the data X and Y. Okay. So now we will make the table. This is the student. This is Rx, rank for X. This is rank for Y. And D equal to what? Rx minus Ry. Then we will find the D square. This is equal to what? D. This is D square. Okay. So now this is the value of A, B, C, D, E, F, G, H. Right? Okay. So for student A, we have find that the rank for corresponding to data X is 7.5, student B 4, this is 6, this is 1, this is 2, this is 5, this is 3, and this is also 7.5. And RY is also what? 7, 4, 6, 1, 3, 5, 2, 8. Right? So now we will find the difference. This is what? 0.5. This is 0, this is 0, this is 0, this is minus 1, again this is 0, this is 1, and this is what? Minus 0.5. And if you want to find the square of these things, we will get that 0.25, this is 0, this is 0, this is 0, this is 1, 0, 1, and this is 0.25. Okay. So here we have find the value of all the value. So summation of D square equal to what here? Summation of D square equal to, if you find the summation of D square, so this is equal to 2.5. Now just apply the formula, we will get the value. So now rho equal to what? 1 minus 6 into 2.5 by n into n minus 1. Here n equal to what? 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So n equal to 8. 8 into 8 square means what? 64 minus 1, this is 63. So you will get the final answer by calculating this. So this is equal to what? 1 minus 150, and this is what? 83, 24, 86, 48 to this is 504. Okay. So now by solving this, this is 504 minus 150 by 504. We will get the value of rank correlation coefficient. Okay. So now also there is another question, and this 5 movie rank based also the here the rank is given. Just you have to find the value of rank correlation coefficient. Apply the similar formula, same formula. You can find the Spearman rank correlation coefficient. There is another problem I here I have given for the as exercise. If you have any problem, then you can just comment on a link, and I will provide the solution. Thank you.